happy to welcome you in a new episode of Not Enough Conspiracy. Absolutely, Richka. And tonight we will approach the subject of the speed of the light, the black matter, the Fermi paradox, the Schrödinger cats, the gravitation, and the curve of the space-time. Episode 1. The speed of light.
Experiment. Knowing that light is a movement of photons, I'm sitting on a beam of light, a flashlight in my hand. I shine forward. The photons from this would therefore travel at twice the speed of light. However, if I turn the flashlight and shine backwards, the photons would therefore have zero speed, which would call into question the very existence of light according to the principle of causality as proposed by Einstein's general relativity, and which explains that our universe exists. This is why the speed of light is considered constant and unsurpassable.
Episode 2. The Fermi paradox.
Stars in the observable domain of our universe, around which orbit planets in the habitable domain that can support life for a long enough time so that it develops in a sufficiently intelligent way so that it can manifest itself in a way that can be seen from our planet, the number of civilizations within our reach should be staggering. However, despite our decades-long efforts to observe them, we see nothing. One of the explanations proposed by scientists draws a parallel between a termite mound who doesn't realize that there is a building right next door. We would be the termites, incapable of comprehending the existence of the inhabitants of the building, which leads to the second explanation, namely that none of these civilizations want to meet us.
Episode 3. The Schrödinger cats.
We can say that the box contains a cat. However, time passes and we no longer know if the cat is dead or alive. According to the theory of quantum superposition, we can affirm that the cat is both dead and alive, which raises the problem of state superposition. It is only by opening this box to observe the cat's condition that we will disrupt this balance. This demonstration is also valid for any known or supposed form of life in the universe. It is from this theory that scientists plan to develop the quantum computer, which would enable the development of unparalleled computing power, such as exploring all possible routes in a maze, and this in one go.
Episode 4. The Black Matter.
Movements and materials known in the universe, we arrive at an insoluble equation, namely that the galaxies would not hold themselves together and would shatter. However, they behave well, and have done so since their training. Hence, the assumption of the existence of dark matter and invisible, impalpable matter, and therefore with which we cannot interact but would hold the galaxies in one piece. One of the consequences of the presence of dark matter is the cooling of the universe that we are currently observing.
Episode 5. The Gravitation.
fundamental interactions that govern the universe. Gravitation is the physical interaction responsible for the attraction of massive bodies. It manifests itself in particular through the Earth's attraction, which holds us to the ground, or other natural phenomena, such as tides, the orbit of the planets around the Sun, or the sphericity of most celestial bodies. Newton's law of gravitation states that the force acting between two bodies is exerted in a straight line between the two bodies in a proportional manner to the quantity of matter present in bodies. Nevertheless, Einstein's theory of general relativity considered gravitation as a manifestation of the curvature of space-time under the effect of the energy of the matter found there.
Episode 6 E equal MC2.
Special relativity, the equality E equals mc2, known as Einstein's relation, links mass and energy. This relationship means that a particle of mass m has an energy E called mass energy, whose value is given by the product of m times the square of the speed of light in a vacuum. This formula explains the energy released by nuclear fission and fusion. Due to the enormity of the C2 factor, a tiny loss of mass can release a considerable amount of energy. For example, 1 gram of matter annihilated by collision with antimatter corresponds approximately to the energy released by the nuclear bombs of Hiroshima and Nagasaki. At the same time, this equation tells us that if we knew how to control this energy by breaking atoms, we could have almost unlimited phenomenal energy at our disposal without harming the environment. Hence the research over the past century on nuclear energy.
Episode 7 The Butterfly Effect.
Deterministic laws of Galileo and Newton, the initial conditions would allow to determine the future state of a system by following the principle that any action X would have consequences Y predictable thanks to mathematical formulas. The meteorologist Lorentz answers that minute variations between two initial situations can lead to unrelated final situations. He thus asserts that it is not possible to correctly predict very long-term weather conditions because, on the one hand, according to chaos theory, uncertainties are inevitable, and on the other hand, man cannot take into account all the elements which constitute his environment. Lorentz philosophically illustrated his theory with this formulation: can the flapping of a butterfly's wings in Brazil cause a tornado in Texas? Hence the term butterfly effect.
Episode 8 The Doppler Effect.
Is the frequency shift of a wave observed between transmission and reception measurements, when the distance between the transmitter and the receiver varies over time. The Doppler effect is essential in astronomy because it allows the radial speed of a star to be directly determined. By studying its spectrum, we notice a shift in the wavelength of the light it emits, towards red when the star moves away from the observer and towards blue when it approaches. It is thanks to this that we were able to specify the movements of matter inside the Milky Way and determine its spiral structure. Incidentally, we can observe the Doppler effect on our scale, as for example by the shift in sound frequency and therefore tone of the siren of an ambulance, which would come to pick us up, but would not stop.
Episode 9. The Wormhole.
Is a hypothetical object that would connect two distinct regions of space-time and would appear, on one side, as a black hole and, on the other side, as a white hole. Imagine space-time not in 4 dimensions but in 2, like a sheet of paper, whose surface would be folded on itself. Cross this sheet using a pencil, creating 2 holes, A and B. Point A directly touches point B, the meeting of the 2 points corresponding to the wormhole. In terms of space travel, going from A to B would be much faster than time that it would take to cover the distance separating these 2 points in a linear manner, as on the surface of the leaf. Using a wormhole would theoretically allow travel from one point in space-time to another, making travel possible in time or at least across very distant galaxies, which would present notable travel facilities such as, for example, go get the bread from your sofa.
Episode 10. The Type 3 Civilization.
Civilization according to the Kardashev scale, it is possible to classify civilizations according to their level of technology and particularly in view of their energy consumption. The most successful would be Type 3, namely after having passed Type 1 consisting of using all of the fossil energy on its planet, Type 2 which consists of exploiting all of the energy of its star, Type 3 is characterized by the colonization of its galaxy. A second explanation of the Fermi paradox is that no civilization was not able to pass the Type 1 stage, which would result by the failure to control the energy of the atom and the self-destruction by their fossil energies. For the moment we are the only known civilization and we are Type 0.7, which in addition to being quite mediocre on this scale, is not very reassuring given the acceleration of the damage already caused.
Episode 11. Retrograde Space Travel.
Imagine you invent a time machine and you decide to go to the past to kill your grandfather before he had children. You could not exist, and therefore go and kill your grandfather. This temporal paradox makes time travel to the past very unlikely. Some researchers attempt to respond to this problem and propose, for example, that you would be stuck in an infinite time loop in your one and only plane, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity, to repeat the same action over and over again for eternity.
Avec Modern of Conspiracy.